We're going to do the same operations, but we're going to do this from Venn diagram standpoint. We are going to be looking at the entries here, the elements. Remember, Roman numeral 1, 2, 3, 4 are just naming the positions here. They're not the elements. The elements are pi e, square root of 2, square root of negative 1, e to the pi I, 10 to 100. I can't really read this. I'm going to call it 2 to the na, and then 666. So A union B, and this is where sometimes doing a little bit of coloring in with a highlighter or something can help you out. A union B is all of this, all of those. So my elements there, if we can see through my colors, my elements there are pi, this is A. My elements there are pi E. What's in here is the square root of 2, square root of negative 1, and then these elements over here, e to the pi I, 10 to the 100th, and what I'm calling 2 to the na. I just can't read that. I'm not sure what that is. And it is a set, so we put them in brackets. To do part P, to do part B, erase all of this, so we can start again. And we're looking for A union B not. So the way I do this on a Venn diagram is to color in A union B, wrong thing, A union B, just all of that yellow, but not means I need what's not in the yellow. I'm looking for the complement of the yellow, and what's not in the yellow is just this entry right here, which is 666. Erase. A intersect B is what's in common to these two, which is just right here. That's always your intersection between two sets. So my elements there are the square root of 2, the square root of negative 1, and there's my braces. Erase. Start again. A intersect B not. Well, this is very much related to answer C. A intersect B was this part right here. But because I have the apostrophe, I'm looking for what's not in that yellow colored. What's not in the yellow is this stuff over here. So it is pi e, e to the pi I, 10 to the 100th, 2 to the na, and don't forget 666. It's part of the universal set. It's part of these elements here. E, I need A not intersect with B. A not is everything not in A. So I'm going to color everything except set A. That yellow is not A. And I need to intersect that with B. So I can change color here and intersect it with B. B is this part over here. So maybe just put some dots here so I don't color up everything I've got. So what I'm looking for is what would be colored both yellow and green polka dot. And what's yellow with green polka dots is this part in here, which is e to the pi I, 10 to the 100th, and 2 to the na, or whatever that thing is. All right, to do F, we start with A union not B. A is this right here. And we want to union that with not B. Well, not B is everything except this. So do all of this yellow. And I'm doing union, so I need to write down anything that's colored, whether it's colored yellow or green or both, anything that's colored because it's the union. So what's colored right in here is pi e. What's colored in the middle is the square root of 2, square root of negative 1, and what's colored out here is 666. And it is a set. Don't forget, your braces. A little more complicated with the Venn diagram. Remember your order of operations. We need to do what's inside here first. So A union B is all of this. A union B is all of this. But we need the elements that are not in A union B because of that apostrophe. So the elements that are not in A union B are these right here. So this is 22, 27, 30, 37, 46. I'm not going to fit over on that side. We'll put it in the front. So this is our A union B complement, or A union B not. I need to union that with what's in A. So what is in A is all of this. So those elements are 2, 6, 8, 11, 14, 17. We are unioning those, so we are just going to throw them all together within one set, which is 2, 6, 8, 11, 14, 17, and then list the others, 46, 22, 27, 30, 37. The next part is to find the number of elements in the union of two finite sets. Remember, the number of elements is called the cardinal number. So we want to find the number of elements in the union of these two sets. We know union means throw it all together. So the union of set A and B, you might think, hey, there's 5 elements in A, there's 5 elements in B, so it makes sense that the union of those two sets would be 10. Is that right? Well, let's make a list and count them and see if that is right. In my first set is A, E, I, O, U. Look at the second set and don't repeat anything. I don't need to write the A because I already have it. The next thing that comes up is B, C, D. I already have E. I don't need to write it again. Count that up. 1, 2, 3, 4, 5, 6, 7, 8 elements in the union. Now, why would I get 8 when I actually wrote those out? Because when I counted 5 here and 5 there, I was actually counting the repeats. A occurred twice, so I counted it twice. E occurred twice, I counted it twice. So one way to get the cardinal number of the union of two finite sets is to go ahead and just write it out and then count up your elements. But if the numbers are too large, that just doesn't work very well. So we use this formula that says n of A union B. Remember, n stands for the number of. So this is the number of A union B equals the number of elements that were in A plus the number of elements that were in B, and then subtract away the intersection of A and B. What does the intersection of A and B refer to? It refers to this A and this E that we counted twice. That was our overlap. That was our intersection. So let's take a look at this from the formula standpoint. How many elements were in A? 5. How many elements were in B? 5. How many elements are in the intersection of these two? 2. And if you add that up, 5 plus 5 is 10. Take away 2 is 8 elements. So when you're asked to do this, you're being asked to come up with the number, not necessarily the individual elements. One from the book. According to factmonster.com, among the U.S. presidents in the White House, 26 had dogs, 11 had cats, and 9 had both. So having dogs is our set A. Having cats is our set B, and this idea of both dogs and cats would be A intersect B. So our formula to find the number of elements in A union B is the number that's in set A plus the number that's in set B minus the number that's in the intersection. So the number that's in set A is 26. Those are the guys who had dogs. The number in B is 11. Those are the ones that had cats. And then the number that's in the intersection of both dogs and cats is 9. Take away that 9 because you already counted it one time as a dog. You already counted it one time in the cat set. So we need to take away the overlap. Add this up is 37 minus 9 is 28. More Venn diagrams. Use this Venn diagram to determine the number of elements in the complement of A. So I start out with let's just find the complement of A. Here's A. and we need everything not in A. A was the yellow. Everything not in A is the stuff outside of the yellow, which is 3, 4, 9, 18. It's a set. I need the braces. Do one more with the formula. Set A contains 21 elements, set B contains 13 elements, and there are 3 elements that are in common. So if I want to find the number in the union of A and B, it is simply the number that's in A plus the number that's in B minus the number that's in their intersection. So what's in A is 21, what's in B is 13, and there are 3 that are in common to both. Add all that up and you get 31.